Thank you, sir. Thank you for the brief introduction. So thank you, participants, for joining early this morning. I just want to briefly introduce you to Dr. Praful Pai. He is also with me in this call. He also works in the same team as the education team at MathWorks India. I am based out of Hyderabad. And I am the point of contact with MathWorks at NIT Rourkela. Praful is based out of Delhi office. So let's get started today. Before starting, if you have any queries during the presentation, please feel free to post your queries in the chat box. Praful will be handling the chat box for answering all those questions. Let's get started. So this is going to be the introduction agenda of today's session. So we will be starting with a brief introduction of 5G and why it is important to use some simulation tool to implement an end-to-end system in 5G. So we will discuss on that. Next, coming to how to do that, how to generate a 5G waveform, how to design antennas and antenna arrays which is suitable to 5G, then coming to channel models, test and measurement, and finally, where to start with, that is resources. So if you see this timeline, of course, you all are faculty, so I believe you already know this. So just to a quick recap of all this stuff. So this timeline shows that how these different generations of communication developed. So starting from 1979, when 1G started evolving with very basic analog telecommunication phone, and then coming to 1991, 2G, we started sending text messages in our mobile phones and all. In 1998, 3G came with a great breakthrough of wireless internet. We started using internet in our mobile phone itself. And then coming to 2008, where 4G, that is the broadband, high-speed internet, cloud, IP, voice over IP, all this started with the 4G. And finally, coming to 2019, just 2-3 years back, this 5G actually took shape, and we started having unlimited, and it promised unlimited data capacity, very low latency, very high speed internet, and so on. Okay, just I am switching off my video just to save some bandwidth. Okay, so what is happening with all this evolution? One thing was very clear, and it was a little concern of the researchers, that as this technologies are evolving, but there are many companies. So there is no single company which makes all of the, like starting from the application layer to physical layer, all the layers. There is not a single company who designed all this. So there are multiple companies, and they collaborate with each other to build a complete system. Now, if there is no uniformity in making all those stuff, in making all those products, in making all those components, then there will be causing a mismatch in different platforms. So what can be done? And from there, it came the need for standardization. So initially, when there was 2G, 1G, and beyond, like 4G, there were different geographical locations, or different big countries. They came up with their own standards, like North American standard, European standard, IEEE standard. So there were also, like, we are saying that we are creating a standard for the uniformity of the system, but also there are different standards. Different countries which are tycoon in those businesses, they are coming up with their own standards. So initially, you can see there are different varieties of standards also available. But as going forward, they also realize that these many standards are not going to work after some time. So finally, they evolved to a single one. They merged all, and at 5G, they formed one 3GPP, third generation partnership project, and they all came together and started introducing the standards for 5G. So in 5G, finally, after lots of research starting from 2010 to 2017, around 17 years of research, finally 5G was launched in September 2018, and the current version, which we are using from since March 2020. And from the very beginning, so like LTE advanced, LTE was there in the 4G, and if you see this timeline, it developed very gradually, like phase A, phase B, phase B. So lots of research were there behind before actually launching the 5G technologies. So let's see what this 5G is special. Why there is so many discussion going on 5G, and how it is special or how it is unique compared to 4G and prior standards. So what it is providing us: self-driving car, industrial automation, 3D videos, smart home, smart city, workplace cloud, mission critical applications, and all. But if you just notice here, different applications, for example, self-driving car, or if it is a mission critical application. So all these things, what one thing is common, that the communication should be very reliable and very fast. Otherwise, it is going to like create accident, it is going to take life, it is going to create some hazards, and so on. So one thing is clear: the communication should be very fast, it should be secure, it should be reliable, and it should be like very fast data rate should be there. So based on all this, if we are promising to provide all this in 5G, so there should be three main specifications to meet by the 5G technology. And they are URLLC, ultra reliable low latency communication, MMTC, massive machine type communication, and EMBB, enhanced mobile broadband. Now see what all these terms actually promise us. So EMBB, what it is saying? It is saying that we will be having a very high data rate of up to 20 Gbps, which will support us in providing virtual reality, augmented reality, broadcasting, smartphone services, and so on. Next, coming to MMTC, that is massive machine type communication. So it will connect a huge number of machines together so that they can communicate among each other, they can send message, feedback, and make a whole autonomous system by itself. And it is promising that it will provide 1 million devices per kilometer square. And that will help in building industrial automations, industrial IoT, smart cities, and so on. And finally, coming to this ultra reliable low latency communication, which is providing very less latency of less than 4 milliseconds, and that will help us in like in developing vehicular autonomous vehicles, UAV controls, mission critical applications, and industry 4.2. Next, coming to the first point, that is we are providing enhanced mobile broadband. But how is it possible? So there are many possible solutions to get a high data rate. First one is increase the bandwidth, send more and more data. Or either the bandwidth is limited, we have to improve the spectral efficiency. That means we have to send large amount of data using a very small bandwidth. So in this way, we can send more and more data using a limited size of band or limited capacity. Then coming to flexible air interface, we use different antennas to send different data rates. If we send all those, if we transmit using all those antennas, then the total throughput will be increased. And then densification, make the cells smaller and smaller, use macro cells, then nano cells, and so on. But the problem is, if you want to increase bandwidth, you cannot do this in the lower band. So you have to move in the higher frequencies. So before 4G and beyond, 4G and below, we used up to 6 gigahertz. So it is called sub 6 gigahertz bandwidth. But starting from 5G, we are thinking to reach up to 60 gigahertz. That is called millimeter wave. But the problem is, if we are moving to higher frequencies, uh, the consequences are more. The complexity is more. So the legacy system is not compatible with this higher and higher frequency band. So we have to come up with new physical layer, new RF uh, blocks, new RF design, and finally the massive MIMO, the arrays of antennas. So this is the new challenges we have to face when we are using 5G technologies. So let's see about the challenges first. First thing, when we are talking about 5G or any other technology, be it Bluetooth or wireless LAN or anything, the first thing is that should be compliant with the standard that is already proposed, already set by the uh, governing body. In case of 5G, it is 3GPP. So the first and foremost thing is that we have to read all the specifications. We have to read all the set rule under those standard, and then we have to understand the theory first. Then we can proceed working with those technology. The next thing is, after understanding that what is the requirement of the underlying technology, we have to develop such algorithm that will satisfy those requirements. So this first thing, reading, that takes a huge lot of time to read and understand this documentation. Next, coming to algorithm develop, it takes lots of experiments, lots of analogy, lots of analytical work and all. And finally, when we are ready with our system, we have developed our algorithm, the next thing comes how to implement that. That is the first challenge, that is how to implement that. And once it is implemented, it should be compliant with the such and such rules so that it is ready to send in the market. Because if it is not commercialized, if it is not ready to use, then there is no use of like developing all these thing and spending all lot of times and efforts in that. So these three are the main challenges. And the good part is this MATLAB 5G toolbox takes care of all these three concerns together in a single platform. We will come to that how, but before that, just to give an overview. So what this MATLAB 5G platform is doing, 5G toolbox is doing. So the first point was understanding the standard. So what it is doing, it has already included uh, all the toolboxes which is following the standard. So the user, they don't have to really read all the specification and make the whole lot of system by themselves, understanding the background theory. So you are already provided with some blocks which are compliant with those standards. You just have to use those and you can modify according to your needs. So what standards this 5G toolbox or the whole MATLAB supports, starting from this Wi-Fi, very basic Wi-Fi, Zigbee, Bluetooth, also coming to 4G and 5G, right? Next, so what we can do, what is the help of using all the standard? We can develop a end-to-end 5G system. We can generate 5G waveform, which is under different standards, which is already set under 3GPP. And finally, we can test and validate that if we are developing a system, that it is compliant with the protocol. Next, the second thing is we can develop and modify our own system based on this single platform. So if we are working in the physical layer, we can develop baseband, we can design baseband, we can implement a physical layer, we can design RF front end, MIMO antennas, channel propagations, we can include different effects of this channel propagation, fading, and all these things. So this is the second part. So a single platform is giving you opportunity to work on all of these end-to-end systems. So this is showing a basic receiver transmitter uh, block diagram, and starting from the very beginning when there is test signal. Test signal means if you are having some RF signal generator, you are generating some signal, you can integrate that with your Matlab in the computer, and then you can import those signal from there and analyze in your machine. Or what you can do, you can generate your own 5G signal in MATLAB, and then you can analyze those or modify those using your um, MATLAB algorithms and all. So this first importing those RF signal from the hardware you have, then coming to baseband, you can do some baseband processing, upsampling, downsampling, ADC, and all those stuff. And then when it is come to digital part, you can process on these bits, you can add some codes on that and all these things. Then coming to RF part you can convert it to uh, like digital to analog converter. You can use mixer, power amplifier, analog to digital computer if you are using in the receiver side, LNA, and all this RF stuff can be incorporated. And finally coming to the antenna and antenna arrays you can add here. So, and when it is done in the transmitter side, you are starting from the RF signal generator, then coming to antenna, and in the receiver side we were receiving from some antenna, and then again you are processing all this stuff, you are demodulating all, and finally you can measure that what is the end result, what is the received signal. You can measure the, like, you can compare the transmitter signal and the received signal. So all this end-to-end stuff can be done. Now here is one question, that is, for example, you are working on this power amplifier part. So it comes under the transmitter side. So if you don't have the blocks before that and after that, how you will test that? You have no option to test that whether my design is right or what changes should I make to make it more effective and all that. So is it a very good solution to get all these hardwares and softwares and then integrate it? And even after we do that for the first time, after reception, for example, we have a receiver also, we receive the signal from the air, then we measure at the end state, at the measurement state, we find that there is a huge difference between the transmitting side and the receiving side. So what we'll have to do, we have to again go back to this part and do it again and again unless we are satisfied with the result. But this is not a very feasible solution in terms of time and finance as well. So what this MATLAB platform is providing you, also you can incorporate the effects of channels here. So different fading, different effect of rain, fog, or different delays. If you can already incorporate in your simulation part itself, and from there you can uh, understand what effect is going to happen on the received signal if you are using this particular design, and accordingly you can already change and you can already modify your algorithm or your design so that it becomes uh, workable, it becomes suitable for the real-time system, right? Okay. Praful, is there any questions so far?
No
Or
questions,
maybe
Devarpita.
If I need to repeat anything.
No, I don't see any particular questions from anyone,
Okay.
so maybe we can.
Okay, sure. Okay. And the final step is, once we are done with the model, once we are done with our design and algorithm, we have to deploy it somewhere. We have to deploy it in some hardware system, or maybe we can convert it in different codes to connect it to 5G test bed and all. So for that, uh, this deployment and code generation to another coding languages, this is also possible. And we can also test and validate that whether our system is compliant with these 5G requirements and all. So that can be done at the last stage. So this is showing that if you have generated one 5G baseband signal, you have already designed and all these your algorithms, you can transmit it through some RF signal generation instrument. You can connect it with your MATLAB and then transmit. Or the another option is you can connect it to your SDR and then use for transmission. On the receiver side, just the vice versa, you can receive signal from the RF receiver, or maybe you can use your SDR as well as your receiver and use this signal for the further processing. Then you can use you can convert your MATLAB code to different coding languages like C, C++. Also, you can implement a HDL code. You can generate HDL code, embedded C code, and implement it in targeted FPGA and SoC boards. So just to give you one hint what hardwares MATLAB can support. So here is the list of hardwares. So just if we go down to mostly wireless communication part, so like lab instruments, signal generator and all, you can connect with, and FPGA, then your digital communication signal processing system like USRP, Raspberry Pi, and different measurement and instruments, analog device, ADM, Pluto, like TCP/IP, Bluetooth. All these things can be uh, connected with the MATLAB platform itself. Okay. So what we can see so far, that if we categorize the challenges and the work needed in developing a 5G system, they can be classified, or they can be put in three main buckets. That is waveform generation, that is where to get a 5G signal or how to generate a 5G signal. Next, coming to end-to-end simulation, starting from the transmitter side to channel to receiver side. And finally, the measurement, that whether the parameters, the variables we are analyzing, they fall or they are compliant with the 5G protocol, right? And finally, there is one optional stage, that is connecting with hardware tools or RF tools. That is, you can connect a radio, like a transmitter or receiver, or SDR for as a future step. So just after lots of talking, just let's see that what this 5G toolbox can actually work.
5G Toolbox enables you to simulate, analyze, and test 5G communication systems. The toolbox supports link-level simulation, waveform generation, and golden reference design verification. Using 5G Toolbox, you can generate uplink and downlink waveforms based on 5G NR subcarrier spacings, bandwidth parts, and frame numerologies. With the Wireless Waveform Generator app, you can generate 5G NR test models and downlink fixed reference channels for frequency ranges FR1 and FR2. 5G Toolbox includes functions to generate and configure 5G NR uplink and downlink shared channels, as well as control and broadcast channels. You can also generate synchronization signals and reference signals used for demodulation, phase tracking, channel state information, sounding reference signals, and physical random access channel. You can perform link-level simulations for 5G NR systems with transmitter, channel modeling, and receiver operations. Using CDL and TDL channel models specified in the standards, you can compute the bit error rate, block error rate, and throughput metrics to verify your link performance. Perform practical and perfect channel and timing estimation, synchronization, and equalization, including the use of deep learning techniques. After generating a 5G NR test model, you can analyze your system by measuring the adjacent channel leakage power ratio to verify if you meet the standard requirements. The LDPC and polar coding subcomponents found in the toolbox provide functions to encode and decode transport channels and control information. Perform cell search and selection procedures to obtain initial system information, such as the MIB and SIB1. Perform system-level multi-node simulations, such as physical uplink shared channel scheduling based on various medium access control strategies. You can access all 5G Toolbox features directly as open MATLAB source code and use these customizable algorithms as a golden reference for design verification. 5G Toolbox functions can be converted into C or C++ source code using MATLAB Coder. This enables you to accelerate simulation, access C source code directly, or use it as a standalone executable. To learn more, explore the 5G Toolbox product page.
All right. But before moving forward, I just want to understand uh, among the participants, anyone got any opportunity to work on 5G Toolbox or anyone explored 5G Toolbox already? If you can share in the chat box your experience or on which tool you have worked, on which particular application you have worked. Mm, please feel free to answer. I guess everyone is having access to chat box, right? I hope one or two leads I will get. Anyone got any chance to explore 5G Toolbox or already have worked, used in their application research, or maybe any particular communication related toolbox in a wireless or any other? Well,
Yeah, I
there
don't
is
think maybe
using antenna toolbox. Okay. Okay. Thanks, Udayanand sir. All right, I think it will take some time to come out from the silent zone. But anyway, so if you have any question, you please feel free to write in the chat. Dr. Praful will take care of this answer. All right. So moving forward, let's see how this 5G, we were talking about this 5G waveform generation and all, how this is actually possible. So this is the main challenge, that how to implement that. So let's see whether it is difficult or very easy to do. Just have a look into it. So this is my MATLAB desktop version. Uh, so this I am using 2021B, but 2022A is already released. So if any one of you having MATLAB updated version in your desktop, you can try along with me. So in this MATLAB page, at the top, you can see this apps option, right? Praful, is the fonts readable enough?
yes, Devarpita, I think I can read it.
Okay, sure. Thank you. So at the top, there is one apps option, right? Now, if you just click on this drop down menu, there are multiple apps available here. So there is starting from machine learning, deep learning, math, statistics, control system, automotive, signal and communication, image processing, and so on. Code generation, and many apps are already available here. So what are they? They are user interfaces. So what you have to do, you just import some input, give some input to those apps, and you make some few clicks to analyze those signal, those images, and all these things, and it will give you the result directly, right? Let's see this 5G waveform generator. It comes under this signal processing and communication. So if I click this, so here at the top, you can see different waveforms can be generated from here, like downlink, uplink, in a test model, then your reference downlink, fixed reference signal, uplink reference signal. Also for 4G LTE, you can develop WLAN. Uh, this all these signals can be generated from this app itself. So let's see, we are developing, for example, in a test model here. Okay, so this is my spectrum analyzer, and this is the specification which I am following. So for example, there are two frequency range, one is sub gigahertz, one is millimeter wave. Let's choose the millimeter wave one. And for the test model, I am using, for example, this one, NR-FO2 TM3.1. This is like a particular documentation. And under this is the full band uniform 64 QAM signal. Channel bandwidth, you can change it 50, 100, 200, and subcarrier spacing. And duplex mode, you can change it is TDD and FDD. Let's choose it as FDD, and so on. And then what you have to do after setting all these parameters, you just click on this generate button. So let's click on this generate. See, your 5G signal is ready. Now, for example, if you want to add some impairments in it, for example, AWGN, or maybe phase noise, or maybe frequency offset. So just add some impairment. SNR you can change, it is 20 dB, you can change it to anything 40 dB, for example, and again click on this generator. So it will show you what is the effect of SNR and all this. Okay, SNR is now my SNR has become higher. For example, I make it a little low. See, we cannot really understand that where this I set bandwidth is 50, I guess. Yeah, where this 50 megahertz band is coming, where is the main part, and where is the noises afterwards. So all these are kind of flat in effect of this noise. And we can also use different visualizations. For example, if I want to see this constellation diagram, I can see that as well. So let's see that if I generate, okay, just remove this AWGN. Initially, I am using for taking that there is no impairments. I want to see what is the constellation diagram here. So this is the signal and this is the constellation diagram. Now, if I put some impairment here, the signal as well as the constellation diagram should change, right? So this is as simple as that. And once you are generating this signal, if you have some hardware with you, like if you have some transmitter or SDR, you can connect it with your MATLAB, and from there you can directly transmit from here. Or if you don't have, you want to export it to your MATLAB workspace, or maybe you want to save it in a file, or you want to like generate script that how this UI is working, how this how this waveform is generating. If you want to analyze all those and if you want to make some changes in your code, just click on export MATLAB script. Just a minute. I think my mouse has stopped working. Okay. Okay. So if you just export MATLAB script, it will generate the code by itself. You don't have to write anything. If you are good at coding, if you want to make any changes or you want to understand every line, each and every line, you can do that. But you don't have to write the code from the scratch. So this is my waveform generation. Next, we see how to design antenna. Someone told that they have used antenna. So for others, there is another app under the same signal processing and communication that is called Antenna Designer. Sir, did you use Antenna Designer app? Did you got any chance? Who answered first? Udayanand sir? Did you use Antenna Toolbox or you developed your own antenna by writing code? Okay, that's great to hear. He has already used antenna app, right? So for others, there is who is yet to explore what is there. There is one antenna designer app. So if you just click on this app, just click for at the beginning, click on this new option. Or if you have designed already an antenna, you can and saved somewhere, you can also open directly. So there are different antenna options given: dipole, horn, uh, and cone antennas and all those stuff. So they are helical antennas and all. So different antennas you can choose from here, Yagi Uda. And from then I am using a simple dipole antenna here for this demo purpose. And there are different radiation patterns you can choose: directional, omnidirectional. Let's choose it omnidirectional. Polarization, you can use different circular polarization, linear polarization, and bandwidth also you can choose different bandwidth for which you want to see the radiation pattern. Then also you can use some backing structure here. I'm not choosing anything. And frequency you can also set. As we are um, talking about 5G, let's choose some gigahertz band of like 24 gigahertz or something, or maybe 30 gigahertz. Okay, and just click on this accept. Right, so at the left side it is showing uh, the length, width, then your different conductor material, different loads, frequencies, and all this feed location and all this stuff. So I am not changing anything here. I'm just clicking apply. If you are good at antenna designing and if you are expert in this domain, you can like tweak a little bit, you can modify according to your need. And then just I want to see, for example, the 3D pattern, 3D radiation pattern of this dipole, simple dipole antenna. Just click on that and see. It is showing you the radiation pattern. So maybe it is very simple for you, for faculties, but when we are teaching to students, it is very interesting for them to understand that how omnidirectional antenna actually, radiation pattern of an omnidirectional antenna actually looks like. Or you can also ask them to change the some of the properties and see how it is changing, how is the effect of like linear circular polarizations and all this stuff. So it is very helpful, very uh, fun part for the students to teach. And similarly, if you want to like check this azimuthal pattern, elevation pattern, and so on, that is also possible. And finally, if you want to export, you can generate script from here or directly export it in workspace and use for further processing. So this is for antenna design toolbox. Then there is another toolbox, another app that is called antenna array app. So when we are saying arrays of antennas. When we are using 5G, we have arrays of antennas. So single antenna is not sufficient for our purposes. Just click on new. This is another antenna array designer app. In the same signal and communication tab, it is there. You just click on this new. So it is showing you a array of 2x2. At the bottom, it is visible, I guess. It is showing antenna size 2x2. I can change that to anything, 4x4, for example. Right? So it is showing now a 4x4 antenna array. This is the XY direction 2-dimensional view, and this is the 3-dimensional view. And all these antennas are dipole antennas here. Okay. So here also I can check different, like whether this pattern should be circular or rectangular. Just let's keep it rectangular here. And then I am choosing some frequency, for example, 30 gigahertz, let's see, and accept. Okay, so it is also showing the spacing of different antenna elements, column spacing, row spacing, then your different antenna elements, its width, height, then your conducting material, and all those stuff. You can change. You also can change and set according to your need. I'm not changing anything here. And from there, if you want to see the 3D pattern, just click on this 3D pattern. So this is the radiation pattern for a 4x4 dipole antenna. So this is my antenna array dimension, array, what antenna array looks like, 4x4, and this is the radiation pattern of the same. And if I just click and drag, it will move accordingly in 360-degree direction. Right? And finally, you can export and use for further processing. Also, this azimuthal pattern, elevation pattern, and S parameters. Yeah, this is the X parameters for all 16 dipole antennas. Then your impedance of this is for element 1, you can change. And for example, for element 10, you want to see, it will change accordingly. Right? So this thing can be done. Okay. So we have already completed this part. Just a quick check. Any question with these apps?
So there is one question, Devarpita, on real-time interface for 5G applications. So real-time, is that supported? So possibly this is about the wireless waveform generation and interface with the instrument. So if you could maybe quickly open up an example on that, that would be useful, I guess.
Okay, so real time, I mean, connecting with the hardware and then or transmitting through a hardware, you are.
Yes, over the air transmission and.
Okay, sure. Okay, thanks for asking this question. Just let me quickly open up a example. I think this is for satellite communication. I have to find a little bit, but it is possible. The answer is, if in one line, it is possible. You can generate a signal and connect it with a, like as I showed you the transmitter tab in the 5G waveform generation app. You can connect a hardware or HDR and can transmit in real time. That is possible. Praful, if you find by the time, if you can share the documentation link, or I can also post it
sure.
after the session.
Yeah, I think we've posted the link.
Okay, thanks. And thanks for asking this question. Okay, so we have already seen all those antenna designing, antenna array designing. And okay, so one interesting demo I would like to share with you. So what it is showing that, okay, we always say that we have designed an antenna. This is going to be the radiation pattern. We have to improve the radiation pattern to improve the coverage and all this stuff. But how actually it is look like? Usually we don't like have any visualization or cannot present any visualization to the student when we are teaching this antenna radiation pattern, that how it actually looks like. So on that, I want to show you one interesting demo I have. Just let me open that quickly. Yeah, this one. So this is one demo on antenna array beam scanning visualization on a real-time satellite map. So if I what it what is the objective of this experiment? That is, if there is one antenna and I put it in a particular location in a map, or maybe in a physical location, what what would be its coverage area? Whether it is like blocking some signal, or whether it is providing sufficient power to the nearby neighborhood, or nearby, like if there is a field or if there is a river, there is no need to focus in this direction. Instead we can focus towards the roadside where these vehicles are moving and all this stuff. So this is going to be a very interesting. So this is one example I have. So what I have to do, you can also access this example. Just type antenna array beam scanning visualization on a map, and if you open it in a MATLAB, or maybe I can also copy command and open it in desktop version. Yeah, so this is the code. Entire code is given there. So what you have to do, you have to uh, run line by line. But before proceeding that, I just want to like ask, how many of you are familiar with LiveScript, MATLAB LiveScript? If you can quickly answer in the chat box yes or no, whether you are familiar with. I guess who are not familiar with LiveScript, this script looks little uh, different from what we usually use in the editor, right? So anyone who is familiar? Okay, Ifran, Irfas ma'am. Yes, okay, okay. Then I'm not going to demonstrate what LiveScript is. I'm directly going to the code itself. Anyone wants me to demonstrate what LiveScript is? Okay, I'm getting one answer, no. Okay, just to give you a quick uh, heads up, what is LiveScript? So in your MATLAB, okay, I'm getting more answers on no. So in your MATLAB, if you go at the top, if you see, so or maybe if you go to the home tab, you can see two options. One is new script, one is new live script, right? So usually we do new script, but in the new MATLAB feature, in the updated version, I'm not sure from where it started, but most of the updated version has this live script. So if you click on this new live script, it will take me to a page like this. So how it is different from the normal editor and live editor? In live, so at the top also you can see this live editor tab right here. So what is the difference between normal script and live script? In normal script, you only write codes, MATLAB commands you just write. But in live script, you can write text as well as script parallelly. You can also add links, pictures, uh, and see the output just in line or maybe just side by side. So how it is important when you are demonstrating some student or someone, or maybe demonstrating some in some presentation, so you can just run bit by bit of your code and you can show the corresponding output at the same time. So you don't need to run the entire code for getting the output and then just uh, explain the outputs one by one. This is the one thing. Second thing, when you are writing code in parallel with text and pictures, and you are attaching this corresponding useful pictures with those with the explanation that what exactly you are running in this code, it is very helpful for others to understand. If you are generating some report, if you are generating some project proposal, or maybe some lab manual for the students, it is very useful for them to understand what is the theoretical part in background. So this is the second thing. And third thing is, uh, mostly we see when teachers give MATLAB assignment, the students write the code, give the code file to the teachers, and teachers have to check line by line of this code, right? Or maybe if you are copying this code or sharing this code to someone, or maybe you are writing in a report, you have to copy the entire code and then you attach it in your doc file or latex file, and then you convert it to a PDF. This is the usual practice. But what if you have 1,000 lines of code? You cannot copy line by line. So for this, in live script, you can directly export your code, your entire discussion, your entire explanation that what is written in a particular line and all this stuff directly to the PDF format or any other format of your choice. So these three are the main benefit of live script. Let's see a few examples. So if I just go to this live editor tab at the top, there are two options. One is text, one is code. So if you see this gray bar here, that means it is the space for writing the code. And that's why this code is now grayed out and text is highlighted here. Now, if I just click on this text option, this gray bar is not there, but I can write any text here. For example, I am writing uh, welcome to 5G uh, workshop, right? Now I want to write one line of code. So what I will do, I will change this text to code option. So now this, as I am writing text, this text option is grayed out. This code option is highlighted. I just click on this code. It will show me the gray bar again. For example, I write, let's draw a sine curve, for example. So I write p equals to 1 is to 10 is to 1000, right? And I write a equals to sine uh, 2 pi f t, where if I have to specify, for example, it is like 30. Just randomly, I'm saying, or 300. Okay. And I want to run this code. But just let's see. So what is happening? It's showing me the output at the side of the code itself. Or if I want, I can also change it just below the line of each code. So at the right side, there are three options. That is output on the right. So all the outputs will come at the right. Just let's plot t comma a. Okay, so if I choose this output at the right side, so all the outputs are coming at the right half of the screen. If I choose the output inline option, it will come just after the line of the code. So you don't have to actually relate and explain each line of the code separately. It is self-explanatory in that manner. So if I write p equals to 1:10:1000, what is the output coming? It is shown just below the line of the code. Similarly for others as well. So if I just give the plot and it is showing me the plot, and if I write some description here, for example, I am plotting a sine signal, right, with this much frequency or so, you can write the explanation. You can also add some links to references, you can also add some picture and so on. Now if I want to again write some code, I will go to the sorry, if I now I am in a code mode because this is the grade bar here. If I want to again write some code, for example, this part is over, I want to plot another cos signal. Next, I am plotting a cos signal and so on, right? So this can be, we can switch between the text as well as code. Also, not only that, and apps and everything you can use as you can use in the normal MATLAB itself. Also, for example, you want to check, okay, I'm changing it here itself. Where what we have done here, we have written if, that is frequency, a particular value. Now what if I want to check for 1,000 frequencies or for 100 frequencies? I cannot write this code for 100 times. I cannot write this code for, even if I write for 10 times, 20 times, it is very large number, right? So what I can do, instead of writing it a particular value, in the live editor section, it gives me option of control, right? So if I just click on this drop down, I get different options like numerical slider, drop down menu, checkbox, edit field, buttons, and so on. So I choose this numerical slider here. So if I choose numerical slider, it gives me option to set some minimum value and maximum value. Let's set the minimum value as 100 and maximum value 1000, and in a step of 100, for example. So all these fields are editable. Label is if you want, you can also change it to frequency or something. And so default value is your, I mean, when you are not using the slider, it will show you as 100, that is the minimum value, and that's it. So now you have this slider mode on. So what you have to just do, this is for 100 frequency, 100 anything, 100 your unit is depending on you. So it's the sine curve. If I just change it, I think, okay, just let's show it in the right side. So if I just change, slide this frequency, every time the sign is changing accordingly. So see, just by sliding this button, I can check at a time in a single code itself for all these frequencies starting from 100 to 1000. All 100 frequencies in a gap of 100, that means all 10 frequencies I can check at once, right? So this is one thing. And there are other more options as well. So I am not spending much time on this live editor itself. So there are options of tasks, like if you want to create a plot. Okay, just let me show this plot option. If I want to just create a plot, I just choose this plot option. Different plots are there. So according to your variables available, whether you want to plot a single 2D one or surface plot, scatter plot, bar chart, histogram, contour plot, and many other options, area, staircase, pie, uh, polar plots, and many other options are also available. So what you have to do, you just choose the type of plot you want to use, and it will ask you for your like x variable, y variable, and so on. So x variable is my t here, y variable is my a here, a is my sine curve, I have named this as a, and just it will give you the, just okay, just to show you, just remove this traditional plot option and run the code, and it's giving me a like it generating the plot itself. Even I am not writing the code. But if I want to write, I want to see the code, just click on the three dots here at the right top. It gives you option like control and code, both you want to see, or controls only. So this is the user interface. It is showing the control only. If I want to see the code, you can just use control and code. So this is the control space, and the corresponding code is already written here. So I am not writing anything, it is generating by itself. So this is the good part. Okay, another one thing I just want to tell you, that in normal editor, what happens that if I want to run the code or run any section, usually I cannot see the output separately. I have to run the entire thing, then I see the output and sort it out. But here you can also break the entire code in smaller parts. For example, after this plotting is done for sine signal, I want to break the section and go to next section for the cos one. So what is the option? After the last line, I will choose this option, section break, right? So once this section break is done, now if I plot a cos signal, for example, b equals to cos 2 pi ft. Okay, now if I want to run only this first part, this sine sig part, I don't have to run the entire code, right? So what I will do, I will run only this blue bar at the left. The hand sign is showing here. I will just click on that. It will show me the first part. And if I want to run the second part, right, small, I will again click on the left side, left of this particular section, and it will provide me the output of this particular one. So this is like if you have a very large code and you want to explain the outputs step by step, it is very useful for that purpose as well. Okay, no more on live editor. It is just to give you one overview. Let's come back to antenna array beamforming example. So it is written in the live editor. As you can understand, I have some text and as well as some codes here, and I am showing this output at the right side. Let's clear all the output from the past. So I am first, what I'm doing, I am designing a dipole antenna. So let's click the first section. So some variables you can see here, it is already generated. That means this first part is already executed successfully. Okay, so there is no visualization, so output is not coming on the right side. Next, using this antenna, I am replicating it for 7x7 times, and I am generating a 7x7 rectangular antenna array. Let's see. So this is my antenna array, radiation pattern, 3D directivity, and so the output is coming on the right side, right? Okay. Next, what I am doing, I am specifying the location of the transmitter. So here my location is Washington Monument, I'm putting my transmitter there. I have provided this latitude and longitude. I have provided the antenna height and frequencies, and I want to see the location in satellite map or maybe any geographical map. So what I am doing, I'm just running this section and let's see what's coming up. So here, if you realize that one picture is added here in the code itself, it is not the output, it is a picture screenshot taken, and so this is the output. It is showing the satellite map. It might take some time to load. You can choose your college building as well. Okay. Next, what I am doing, I want to realize that if I put my antenna there, this 7x7 antenna, this is the directivity pattern I know. If I put this antenna at this particular location, how this radiation pattern is going to look like. So let's see that. Just allow me some time. I'm changing my mouse. I think this battery is gone. Okay, yeah. So let's run this section. Okay, see, so it is showing the radiation pattern in the map itself, that what is going to be the how it is going to transmit if I place this antenna transmitter in this particular site. All right, so but if you see in this direction, most of the parts are field, empty ground, but all the buildings and road, like human population, is in the right hand side, right? So intuitively, our target should be to provide more and more signal towards the building and the road side. Okay, let's see. Next, what we are doing, we are trying to identify what are the receiver locations. So if there is no receiver and I am only transmitting, it is not going to be of any use, right? So next, what I am doing, I am setting some receiver locations around the transmitter side. So these are my receiver locations. So all these are my receiver locations. So if you just change it to satellite part, and if you just zoom it a little bit, okay. So here are two receivers on the left side. There are two, one on top, one at bottom, and one is there at the right corner, right? So these are the receiver locations. So our objective should be transmitting in a direction that we can cover more number of receivers at once. Okay. Next, if you can also zoom this map and see that where exactly these receivers are lying and all this stuff. So there is probably some university and it is lying on the rooftop of this university and so on. It is provided on the field. It is like just by the side of a field and this stuff. Okay. Next, let's see. Next, what we'll do, we will change the angle of the array, and we'll see how this radiation pattern is changing with the change of angle. Why it is important? by changing the angle, we can figure out that at which particular angle, if we set the antenna array, it is going to cover maximum number of receivers at once, right? So let's see. If you can realize, the radiation pattern is changing from time to time at different angles. This is a 30 degree like 30-degree step, so it is changing in each 30 degree. Just to confirm, Praful, this graphics is visualized, right?
Yes, Devarpita, I think I
Oh.
can see it in increments.
Okay, sure. So it is changing like this. Okay. Next, what I am doing, okay, this is the radiation pattern. We can understand, we have seen the radiation pattern where the maximum, in which direction the maximum power is going and so on. Now I want to find the coverage area of this. What is going to be the coverage area of this particular transmitting antenna, provided these are the radiation pattern of this antenna. So let's just plot the coverage map. So coverage map, just when it is loading, I just want to show you how it is interpreting. So, okay, it is already loaded. So if you see, if I put this antenna straight at this position, the coverage is going to be up to this point. And this green signal means the strength is very good. Here it is given that minus 75 dB after dBm. After that, sorry, the green is not that good. After that, this is yellow, this is red. Okay, but entirely this is the coverage area. So let me show you how these coverage areas are mapped. So this is the radiation pattern of the antenna. This red color in radiation pattern is mapped to green color here. Then as the power is decreasing, this orangish part is yellow, and then finally light green or orange. In this way, it is being mapped. Now, as we change the angles of this radiation pattern, uh, let's see what is the effect of coverage area if we change the angle. So in the next part, we will see how this coverage area is going to change with change in angle of the antenna array. So this is the first location, right? So every time it is loading the angle, new angle, and it is changing accordingly. And just to give you like a hint, I'm not doing anything. It is running by itself. So see, here also there are, this is also a very crowded place on the left, right side, but there are no receiver available at that location. So there is no use of transmitting in those direction if receiver is not there. Now it has covered one receiver. Yeah, see, here in this direction, it finally covered two of the receivers together, right? So this is the best position as of our setup, because at a once we can cover two receivers here. Okay, so this is what I wanted to show you. You can also like ask your student, or you can also check by changing different parameters, different antenna patterns, different you can use for different antennas as well, like what is going to be the effect in coverage area and in radiation pattern. And you can always place it in a particular satellite map and can show that what is the effect in your surroundings. All right, let's back to the presentation. Stop. All right, so up to this point we have already covered. Next, coming to channel modeling and precoding, this is unfortunately no direct app available for that. You have to write code for it for doing this. But also there are lots of examples available, ready-made codes available. So if you want, you can take references from there, and then when you are comfortable with that, you can change and write your own codes in those domains. So the two different channel propagation models available. The one is the TDL channel and one is your CDL channel. One is 2D and one is 3D. So TDL is tapped delay line and CDL is clustered delay line. So different channels available. Now, how to implement, where to place those channels, right? So if you want to test your channel model, if you want to test like what is the effect is going to be of your channel, so you have to design a end-to-end link level simulation. Now for this you have to start from the transmitter side at a downlink shared channel, then you map it to physical downlink shared channel, do some pre-coding, and then convert it to OFDM, and then apply some channel model here on the receiver side. Again, do some synchronization, OFDM demodulation, channel estimation, decoding, and finally decoding in the logical channel itself. And if it is not satisfied, if it is not transmitted properly, it will send you some HARC to perform this transmitter again, right? HARC is hybrid automatic repeat request. So if you see, okay, just let me open up the code available behind it. Not this one. Yeah. So this is the code. This is already available here in the documentation page. So what it is doing, it is implementing all these steps one by one, starting from downlink shared channel, physical downlink shared channel, then pre-coding OFDM propagation channel, adding some noise in that, and then doing some time synchronization, demodulation, channel estimation, and finally decoding. And if it is not transmitted properly, it is sending some HARC and again requesting transmitter to resend the packet. And if you see the output, so if you just notice in this output, it's starting with giving me message that initial transmission to, so till it is transmitting successfully, it is showing initial transmission, and this is showing retransmission. That means the previous transmission got failed, and once it is successfully passed again, it is starting transmitting the next signal. And this is the like plot of the throughput, SNR versus throughput. So I leave it to you to explore by yourself. Also this in 5G there is one important thing, that you can sense the channel information beforehand by sending some sound reference signal. So here it is showing that you can send some sound reference signal, and from there you can, if you find the channel is good or in a particular direction you need to transmit, you can set your beam according to that, and you can send your message signal on this beam. So let's see how it is happening. This is showing a block diagram of MIMO FDM data flow. So before sending the message itself, we are sending the sounding signal. We have some preamble we are transmitting in through a MIMO channel. Then in a WaveDM receiver, we are estimating that MIMO channel, that what is the receive signal, and we are by singular vector decomposition, we are generating the precoder vector to And precoder vector is giving us the direction in which the maximum power, if we multiply it with the message signal, it will transmit in a particular direction which will provide the maximum power. So this, once it is done, once the channel sounding is done and we get the information about the channel, then finally the data transmission and reception is happening. So this is the data coming from, and we are adding this vector from here, from the sounding step, and we are performing some pre-coding here, and then finally we are transmitting through OFDM and MIMO. We are doing some MIMO and transmitting through MIMO channel as we usually do. So what is the practical approach? Practical approach is we do not calculate, we do not perform SVD every time. We do not calculate the vector exclusively every time. We have some code book. So based on the information we get from the MIMO channel estimate, we refer to this code book and we find the what should be the precoder vector in that case, and we multiply the message signal with that to maximize the signal power or creating beam in that particular format, in that particular direction. Apart from that, so there are, if we are transmitting in MIMO, or there are different scattering happens in the channel. So these scattered effects we can also incorporate in our model. This is showing some ray tracing application in a dense urban area. So these examples all are available. Just let me show you. I just write 5G toolbox here. And if you go to this example tab, okay, just to give you like one heads up that how you can find all these resources. So if you go to this matlab.mathworks.com or maybe simple mathworks.com, so you will be uh, so this page is opening, and here at the top, if you see this support tab, support option here, right? If you click on this support, you will get this documentation option. There are other options as well, like you can find for examples, you can find for recorded videos of all the demos. If you find, you can follow those, and you can write the functions, what is there in the function. For example, you are using some straight away function, mean, std kind of thing, or maybe any kind of function, and you want to understand how to use those, or what is in the background of this background code of this function, that can be uh, viewed from here. So here I am going to the documentation page, and I want to search for 5G toolbox. So at the left side, you see this is 5G toolbox. Many other toolbox, all the 100 plus toolboxes are listed here. There are exhaustive documentation for all of them. So if you are using in communication, this communication toolbox, wireless HDL toolbox, test bench, WLAN, then your RF toolbox, everything is there, right? So I am going to this Bluetooth toolbox and all. I am going to 5G toolbox, and I want to see all these examples related to that. So just go to the example tab just after the documentation page, and you can get ready-made code for all of these applications. So how to do app-based 5G waveform generation, generating uplink signal, downlink signal, then your this example what I was showing, that 5G model transport channel with HARC. All these examples you can get from here, like 5G new radio polar coding, LDPC coding, and so on, right? So you can just go through them and pick according to your need. So moving forward. Okay, next coming to this propagation. Okay, just let me show you some propagation channel model here. So it comes under this communication toolbox. And if I show some examples. So here we can see different propagation channel like urban link and coverage analysis, then your antenna coverage map, then your AWGN channel, the simple channel, co-channel interference, and all these stuff, fading channel you can add. So both in MATLAB and Simulink, all these things are possible. And apart from that, also this rain propagation channel. Let me see. Rain propagation, then your, if it is a urban microcell, then what is going to be your path loss, all these stuffs can be added here. All these effects you can incorporate in your model. Okay, I'm not getting any exclusive example on that. So these things can be done, like if it is a rain propagation, path loss model, and macrocell scenarios, you can incorporate and all this stuff. Okay, apart from that, your scattering effect, path loss effect, fading channels, losses due to gas, fogs, clouds, attenuation, these things can be added and calculated from here. Next, coming to test and measurement. Once you are done with your system, you have developed your system, you have to ensure that your model is providing you a good response, which is acceptable and which is also compliant with your 5G standard. So mostly two types of impairments can be added in the system, and from that we are, in this example we are calculating EVM, error vector measurement, that is the difference between the transmitted signal and the received signal. Like in a noisy channel or some impairment has added, so they are obviously not same, the transmitted one and the received one. So also this kind of analysis you can do. And these impairments are coming mostly from the phase noise and power amplifier. Why power amplifier? Because when we are using high frequency, the nonlinearity at the output of power amplifier is becoming very high, and it is very difficult to handle nonlinear signal. So what we are doing, we have to develop some pre-distorter so that it nullifies that non-linearity at the power amplifier output. So what we are doing, we are passing some signals through a power amplifier. We observe at the output side that what is the non-linearity. We feedback that again at the transmitter side and add some like modification to nullify those non-linearity at the output. So all these designs can be done. Apart from that, this is showing interference channel model, like I am transmitting one 5G signal and there is also a source of some LTE transmission. So how they are interfering and what is going to be the effect at the output. So we can calculate EVM, Constellation diagram, and see that how this transmitter and receive signals are different from each other. Next, the final step, hardware and radio connectivity. As someone was asking if it can be transmitted directly. Yes, it can be done if you have generated some waveform and want to transmit it directly through your RF transmitter, or you can connect it to a SDR as well, like ADM Pluto or so, and using that, or maybe USRP, RTL SDR, anything you can add, and from that you can transmit in real time as well. Also in the receiver side, if you want to receive, there is existing source, you want to receive the signal and analyze for your experiment, that can also be possible. So in summary, we have in this whole circle, we can see that all these three subcategories can be covered, And this completes the whole circle of a 5G design, that is starting from the mobile standard connectivity. Already uh, it has systems which is compliant with the different standard bodies, and you just have to incorporate them together to make your entire system. You can design and modify your own algorithms. You can use different effects or real-time effects in the simulation itself, and check that what is going to be the effect if I implement those signal in in real scenario. And finally, test and measurement, like you can transmit, you can receive, or you can place it somewhere in the cloud or in cluster, and or develop some HTML codes out of it. So all these things can be done. So now coming to a very important question, that okay, you were talking all of this stuff, but why it is important? What is the applicability of all this stuff? So in coming days, we are talking about implementing this massive MIMO technology, vehicular communication, your localization, positioning, tracking in different applications, satellite images, and your radar applications. These are going to be a very important uh, research work, or very important work to be incorporated with. And if anyone is interested to do multidisciplinary research, want to incorporate, want to like collaborate with other technologies as well, other like AI, so that is also possible. There are different examples available on AI for wireless. So if you are interested in that domain, you can just go and have a look in the documentation page. And that's all from my side. These are some of the user stories from industry side, how different industries are using MATLAB tools and MATLAB toolboxes to develop their system. So if you go to this MathWorks website, there is one community page. I think it is here somewhere, or let me just type MathWorks user story. So if you just want to get some idea how others are using MATLAB tools for wireless communication and all, you can just search, or maybe 5G, as we are talking about 5G today. So you can just search for uh, implementation or application from other industry and academic as well. So this is mostly everything from my side. If you want to know more about this 5G NR and what functionalities you can implement, you can go to this video series. This is very small videos of like 1 2 3 4 5, 8 10 12 videos are there, so you can directly go to them, and that's all. So if you have any question, you can ask here, or if you want to see more resources, then also you can ask that how to find resources and all this stuff. And before ending, I just want to show you one more thing. If you are not sure about anything in MATLAB, you first of all, you don't have to remember any code here. If you not sure about anything, you can always search in the documentation, and it will provide you it will guide you to the documentation itself, or you can go to this help option. So if you ask for help, it will open the entire help center. It will give you all the examples and everything. And if you want to know what is there behind any particular function, like here it is directly written design, but what does it mean by design? Because why I am talking that, because most of the time, many times these students ask this question, that why I am using this function directly, what is there at the background. So if you want to know more about any function, just highlight that, right click, and click on open design, right? If you just click on that, it will give you the entire code in background of that. So if students are interested of, or if any faculty is interested, they can refer to this code and understand what is happening at the background, right? All right, so that's all from my side. Thank you for listening for so long. We are talking for around uh, 1.5 hours or more. Professor Shumon, I am
Okay, thank
over
you,
to you.
madam.
Uh, a very good morning.
Thank you, ma'am.
Devarpita,
Thank you, Dr. Shushmita.
personally, thank you for our request and explaining very nicely about the details of 5G NR implementation using Matlab. I hope it will be really very much easy. It will be, they will gather how to implement the, let's say, the channel models, let's say the end-to-end link simulation, let's say the 5G NR waveforms. So all these are quite vital for the current present communication scenario. So I hope all the participants are highly benefited through this lecture. So
Thank you,
thanks
ma'am.
a lot again to the
Professor Shushmita,
any
I have one
I
request.
yes.
If any participant wants to connect with me, I am providing my email ID and also Proful's email ID. If anyone wants to connect to me for any queries or any resources they want, just write to me at my email ID. If anyone
Okay,
gives you any feedback, please
yes,
pass on that to us. It will be really helpful for us to like understand the need better. Thank you, ma'am.
definitely. So, madam,